conducting an experiment that has to do with the vehicle. So you guys will be making your own vehicle, okay? So today, what we will be doing is we will be looking at different stuff about making your own vehicle and how to make it go fast. So we will be making predictions today and trying to figure out different stuff about our vehicles that we're making. What is your favorite way to travel and where is your favorite place to go? Hands? Motorcycle? You've been on a motorcycle before? That's cool. Okay. Where do you go?
It wasn't my country. We wake up basically. Like my brother and my dad and me and my uncle would go on the motorcycle store. Basically a breakfast place.
Okay, that's cool. Anyone else? Kiana?
Plane.
Plane? Okay. Where have you been on a plane?
California.
California. Okay, that's cool. Now, do you think the plane went fast? Slow? What do you think? Fast. Okay. Anyone else? All right, I'm gonna take two more. Helicopter. Okay. Where did you go on a helicopter?
To the Statue of Liberty.
Okay, that's cool. So you got to see the Statue of Liberty.
Car.
Car. Yes, car. Okay, where do you like to go when you travel in a car?
Atlantic City.
Atlantic City. Okay, that's fun. All right, I'll take one more. You. Train. Okay. Where did you go when you took the train? New York. Oh, you went to the city. Okay, that's cool. All right. We're about to play. So what car manufacturer also makes airplane engines? Who can take a guess?
Oh wait. I think wasn't it
Raise your hand.
Rolls Royce?
Rolls Royce?
Yes.
How do you know?
Cause I know it.
How? You're right. It is Rolls Royce. Oh, you want to be an engineer? Is that true? Okay, that's cool. All right, next question. What is the best-selling car of all time? What do you think it is? You think it's B, a Ford Mustang?
I know it's easy. Not easy.
Hold on.
Tesla.
A Tesla? Not a Tesla. Stay in your seat, Davion. What do you think it is? A what? A Toyota. Good job.
We want to see a picture of it.
What, a Toyota?
Yeah.
Remind me at the end and I will show you guys a picture of the Toyota.
I don't know. This is my favorite car brand.
So what we are going to be doing is the balloon car STEM challenge. That's what we will be doing next week. So we will make our own cars and we will see how fast they go. All right, you need to quickly get across town. The only materials you have is a pile of miscellaneous items and a balloon. Your challenge is to build a balloon propelled car that will travel in a straight line for at least 5 feet to get across town. So 5 feet is roughly from here to here. So that's how fast your car will need to travel. They'll need to go at least 5 feet. Yes.
Oh man, I gotta take you.
Yes, you may. All right. Identify the problem. Build a balloon-powered car that will travel 5 feet. Constraints. The car must be propelled forward by the air escaping from the balloon. the car must be sturdy and not fall apart when in use. So the car can't break down, because if a car breaks down, what happens?
It stops.
It stops. What happens, Kiana?
It stops.
It stops. We can't get to where we're going. The car must travel at least 5 feet. The car must travel in an approximately straight line. So it must kind of go straight. So if it wiggles a little, not too bad. But if it doesn't go straight, then it won't work correctly, because all cars need to go straight.
Can we watch that today?
Huh?
Can we watch that today?
Yeah.
No, bleeding.
So, do materials play a role in how fast and how far a car can travel? What do you guys think?
No. Yes.
No?
Yes.
Why, hold on, why do you think no?
I just did a guess.
Oh, okay. Why do you guys say yes? Can I get someone to raise their hand and tell me why?
Cause, like, the materials, like, can make the car faster.
Yes. The materials can make a car faster and can make a car slower. Also, based on the materials, that will be the durability of the car, because if the materials aren't durable, then your car won't be able to function. Yes, Kiana?
Can I hang up my
You wanna
phone?
go see your nurse? Yes, you can go in.
It should-
You sure?
Yeah, I'm fine.
Okay.
Greetings, Science Maximites! I am Phil McCormick, and this is Science Max Experiments at Large. Today, we're going to be experimenting with the balloon-powered car. Here's how it works. Woo! It all has to do with Newton's third law.
Newton's third law. For every action, there is an equal and opposite reaction.
We don't have to do this now. This is all for later. We can build the cars first, and then we can, let's go over here. So how do you build a balloon-powered car? Well, I suggest you be Science Maximites, because there's any number of ways you can build a balloon-powered car. You do not have to follow my design. You should come up with one of your own. It may even be better than the one I built. But I will give you some tips, though, that make it a lot easier. First of all, you need something to stick your balloon on that has an opening on it. I used a turkey baster for this car. I just pop the top off, and remember to tell an adult that you're using the turkey baster, and then you stick the balloon on there, and it allows you to attach something to the car, and it also makes it easier to blow up the balloon. You can use any number of things, even just any kind of tube that you find lying around. It helps you attach the balloon to the car, and it helps you blow up the balloon way easier. The other thing you should think about when you make your balloon-powered car is how you're going to make the wheels roll. Once you've decided on the base of the car, you could use anything, even just a piece of cardboard like this. You can do your wheels in two ways. The first way is to attach the wheels to the axle. This is how I made the axle of this car. I used a shish kebab skewer, and I stuck it inside a straw, just like that. And then I attached the lids to the shish kebab skewer. So the lids and the shish kebab skewer are attached, and they rotate in the straw. That's one way to make the wheels turn. The other way is to tape down the axle, or whatever you're going to use, and have the wheels spin around on the axle. Two great ways to make your wheels turn, and it really kind of depends on the wheels you're using. You can make your own design and keep refining it and making it better and faster, or do what I like to do and make a whole bunch of different cars. So we've got this one. This one I made out of paper plates, and this is a snorkel. Awesome! This one is the rock car. Because there's a rock on it. I've got the dragster model. It's a long broom handle, and it might not work that well, but who knows? And this is my favorite design. It's made out of waffles and an ice cube tray. This is why I make a whole bunch of different cars, because I can race them.
Sunday at the Science Maxidrome. It's the balloon-powered car winner take all drag race. Awesome!
First up, the Eliminator.
Better late than never, it's the procrastinator. crushing the competition. It's the Dominator. Feel the chill of the refrigerator.
Hooray!
And last but not least, the
Regurgitator. Well, when you build your balloon-powered cars, you can figure out what worked or what didn't work and try modifying your designs to make them work even better.
My name is Phil, and I take your everyday science experiments and do them big. This is Science Facts. Experiments at Harvard. Science Facts! At Harvard. Science!
All right, what can you guys tell me about the video? What did you guys see in the video? Back there. What did you see?
That he put the stick into the straw so it can roll.
Greetings, Science Facts!
He put the stick into the straw so it can blow. And then, Kiana,
Like some of the cars like work and the other cars not work.
yes, some of the cars worked and some of the cars didn't work. Does anyone remember what word he used to describe different ways you can change your car to figure out what works?
Modify?
Modify. So what does modify mean?
To like change?
To change. You have something to say? Okay. Make better, yes. Modifying does mean to make better.
Greetings, Science Facts! Woo! Yep.
All right. So, industrial engineer. I have one person that said they wanted to be an engineer. Why do you think that career is important? I gotta call on you because you want to be the engineer. Why do you think it's important? To make new inventions, okay. What about you, Kiana?
To help people like when their cars like broke.
Yes, to help people when their cars break, okay. So understanding the engines of the car, because every car has an engine. So understanding the engine, yes.
I want to be an engineer too.
Oh, you do too, okay. So what can you tell me? Why do you think that this career is important?
To solve people's problems.
To solve people's problems, okay, good job, yes.
Also, it's like you can't afford to buy cars, but you can modify your own car.
Yes, you can make modifications to your own car. I know a lot of you guys watch TikTok. So I see that some people, they take like an older version of a car. So the car, one of the cars we seen earlier, well, we talked about earlier, was a Toyota Corolla, right? So I seen on TikTok, a person took a 2008 Toyota Corolla, and then they took parts of a 2021 Toyota Corolla and made modifications to make the car look newer. So, yes.
My dad has the exact same.
Oh, he has,
2008.
oh, he has a 2008 Toyota Corolla. Anyone else? All right.
Everyone has a 2008
Now we're gonna watch this video. I need you guys.
Industrial engineering
It
is
is about
optimizing the time to finish something.
No, people are
Industrial engineering is a branch of engineering that focuses on making processes better. It's a lot of optimization and making those processes more efficient. So let's just go into applications and see what this even means. And let's start simple. Let's say when you wake up in the morning, your routine is you go from your room to the bathroom to shower, then back to your room to change into clothes, then downstairs to eat, then out the door to work or school or whatever. An industrial engineer would look at that process and say, what if instead you went from your room and took your clothes with you to the bathroom, showered, then changed in there instead of going back to your room, then you went downstairs to eat and leave for school or work. You just eliminated the need to go back to your room after the shower and therefore improved the process and made it more efficient. In this case, you improved time and distance you have to travel. This example is simple but clearly not a career path, so now let's see something more applicable. How can we make going through a line more efficient? At a bank, for example, everyone waits in one line normally. Then you go to whichever teller is available once you're at the front. This is nice because if one customer is taking a while, the people in line will still get to choose from the other tellers as they open, which keeps the line moving. So is this the most efficient? What if they set it up like a grocery store instead? At a grocery store, there are maybe 5 cashiers open and people choose one line to wait in. Can you imagine something like Costco with one line that then goes to multiple cashiers at the front like a bank? Due to the amount of customers, the line would look insanely long and would probably cause a lot of people not to shop there. Therefore not efficient because it's not good for business. So grocery stores and similar places probably have the right idea. But is the bank wrong? Well, probably not. It depends on factors like the amount of customers coming in over a given time interval and the speed to which they are helped and so on. Banks often have shorter lines and less people per hour, so one line for them is probably the best way to go. All these factors are what industrial engineers need to analyze. But now let's look at something like Disney World. Places like this are huge on hiring industrial engineers. Industrial engineers analyze data about lots of aspects of the park to improve wait times for entrance, rides, food, and so on. These parks use techniques to track how long it takes someone to get through a line. Industrial engineers then take this data and figure out ways to improve how the line will move to improve people's experience. Industrial engineers will see data like the average attendance on each day of the week. If it's a low number, then maybe they can change the structure of the line. Some lines you may see weave in and out a lot if it's crowded to make it appear shorter. With new rides and attractions constantly being added, then varying attendance for different days of the week and times of the year, more data samples always being taken, industrial engineers could have very consistent work at places like Disneyland, Disney World, Six Flags, Legoland, and various other theme parks. A project you could see in class, which is also a career path, would be looking at something like Amazon. Let's say Amazon is going to build another warehouse that is going to receive, let's say, 10 million products per week that it will eventually ship out to people. So it might receive 5,000 orders of product A, 15,000 of product B, 100,000 of product C, and so on per week. The problem is, how should everything in that warehouse be designed to make the process of receiving and shipping products the most efficient? How are the trucks going to drop off the products? Should they use forklifts to take the products out of the trucks in pallets, or use more people to unload directly from the truck? What's the time it would take for each? Where should all the products in the warehouse be placed? Well, let's say if product A and product C are getting the most orders and ship out at the same time, put them closer to the door so people can load the truck quicker. Maybe put the least ordered product furthest from the door. But what if it's also the heaviest and takes the longest to move? Will that be worth it time-wise based on the orders it receives? These processes can clearly get complicated. Then a huge career path for industrial engineers would be to help improve and manage the manufacturing process of really anything. Manufacturing applies to nearly every product. Airplane parts, rocket parts, car parts, household appliances, windows, doors, game consoles, candy bars, soda and bottled water, and so on. Now, manufacturing plants are normally a lot of people, each with their own station, and often conveyor belts that move the product through the plant to the people so they can do what they need to until the product is complete. Now, you will not be one of those people with their own station as an industrial engineer. Those are the operators. You will look at the entire process as a whole, manage it, and figure out ways of how to make it better. So let's go really simple. Let's say a plant has 2 workers to manufacture paper clips, and let's say there's only 2 steps. The first worker at station A makes the straight piece of steel wire, which takes 2 minutes. Then it's handed off to the second worker at station B, who uses a machine and bends it into the paperclip shape, which takes 4 minutes. An industrial engineer comes in to review the process and sees that the second worker will have a pileup of steel wires to shape because he's finishing his process twice as slow as the first worker. So the engineer says we should add a worker to station B. So that way it takes 2 minutes to make the steel wire and 2 minutes on average to shape one. Everything flows smoothly and in the same time interval, which means faster shipments and more money. But what if we had 10 workers at station A and 20 at station B? Now we can make 10 times more paper clips to ship off, and that's even better, right? But we also have to pay 10 times more people. Is it worth it based on how much money the extra paper clips make versus the worker's salary? Are those extra paper clips even being sold that quickly, or have we exceeded the workers we need for maximum profit? What if there was like 6 stations like in the real world, and each person took a different amount of time to finish their respective job? How would we ensure minimum pileup of work or time waiting around? Are you seeing why industrial engineers are so important? Optimizing time and even profit is what industrial engineers need to do. The senior project a group of students did was to look at a manufacturing company that made buses. The company was able to make 300 buses per year, but they wanted to make 325 without adding more people or buying more machines. The industrial engineering team looked at the process, saw that the bus had to go all the way around the factory in a spiral-like square to all these different stations, like for putting on the engine, the tires, the windows, etc. Then also people at certain stations needed to communicate very often with people at another station that was far away. The industrial engineers thought of how to move the stations around, so the bus had to move a much shorter distance, and also so workers that need to communicate with each other would be closer together. This may not seem too complicated, but I had to simplify it for the sake of this video's length. But this kind of analysis could apply to any manufacturing process from paper clips to buses to fighter jets. Industrial engineers could optimize the distance nurses have to travel to deliver a blood sample to a lab in a hospital, or timing of airplane arrivals and departures at an airport, so there isn't a long wait time for the plane and its passengers. Really just any process. Industrial engineering is often not high-level math, physics, chem, or anything like that. I don't want to say it never is, but it often is not. It's often looking at statistical data and coming up with solutions through testing or simulation. Industrial engineers will watch the process as it happens, maybe even take a stopwatch and time how long different processes take, collect the data, then they take that time of different processes, the cost of materials, the amount of products that need to be made on a given day, the distances that these objects travel, and come up with ways to make the process better. Note that some of these jobs are things you don't think about. Most people probably don't think Disney World lines are being continuously analyzed and optimized, or that Amazon needs to put that much thought into its warehouse layout. But these jobs do exist because all companies want to cut time and costs, and need to make sure everything gets done on time. Industrial engineers look at the efficiency of processes, but also the cost of materials, the forecasting of future materials needed, making sure everything arrives on time and in the right quantities, that all the machines are working, and so on. They improve but also manage the process. Also note, industrial engineers don't really do the design work. If you want to make lasers, design radar tracking systems, design spacecrafts that can travel faster, design military aircrafts, build synthetic body parts, and so on, industrial engineering probably is not the best for you. Industrial engineers eventually often go into manager positions where they manage people and work their way up in the company, rather than stay and continue optimizing and overseeing types of processes, but of course that is up to you. But if you like looking at the business side of things and increasing profits, optimizing the time to finish something, managing shipment orders, quantities and pricing, statistics, and working with or managing people, then industrial engineering may be good for you.
All right, so now tell me, why is it important to be an industrial engineer? You can tell me. I need to see more hands, or I'm about to start calling based on numbers.
Do it.
So, all right. Do any hands want to go up? Besides the same ones? All right.
To help people, like, in their problems.
To help people with their problems, okay? Such as, give me some examples that they listed in the video. Excuse me, Davion, turn around, face the board. Make stuff more efficient. Yes, getting from point A to point B more efficient and making things more efficient. Yes. To save more time. Good job.
So businesses make more stuff.
businesses make more things. To make time more efficient, Kiana. To save some time. Okay, good job.
Industrial engineering is a branch of
Alright. Using the Newton's third law of motion to move our vehicle. That's what we're gonna be using. So the balloon is going to be pushing forward while the air is pushing backwards. Have you ever blown up a balloon and let it go?
Yes.
I think we all have. We blow the air, and then when we let it go, what happens? Yes. So the air escapes rapidly from the balloon, making it fly everywhere. There will be 3 parts to the balloon car. There will be the wheels, there will be the body, and then there will be the axle. So, what are some things that you've seen in the first video that were used as wheels?
A disco cart.
The disco cart,
Pancakes.
pancakes,
Those were
Waffles.
waffles,
Paper plates.
paper plates, cardboard, okay.
Oh,
Davion,
discs.
this, which ones do you guys think will be most effective?
Probably the cardboard.
Cardboard, what else? This, okay. Now for the body, what are some things they use for the body?
cardboard.
Cardboard? Anyone else? Davion?
Wood.
Wood? Wood? A broomstick? Okay. Oh, okay. Okay, yes. Now for the axles, what can be used for the axles? What's that? So the axle is kind of like what connects the 2 wheels. So yes, it holds the 2 wheels. So let me see, I don't know if there's one over there, but here, I can use this pencil as excuse me. So let's say this is an axle, right? We'll put a disc here and a disc here, and then they will spin together like this. So the axle helps it spin. Yes. Straws, kebab stick, straw, shish kebab sticks, good job.
I know it's just kebab steak, but I said kebab.
So now I want you guys to turn, talk to your elbow partners, and talk about what are the things that you think, wait, my voice is being heard right now, so no one else's voice should be heard. What you guys think would make a best car for you guys, so talk about the materials you guys think would make the best car. That can go, remember, the car has to go 5 feet, it has to go straight as well. Alright, so I'm gonna give you guys 2 minutes to discuss with your partners what you guys think. Okay, so she'll come to you and you two discuss.
What if we use these for the best? Can we shush it?
The body part will be the body part.
Okay,
Yeah.
body.
And the
Metal.
axle will be cardboard.
No, what about the ice tray? No, we need the one that's the lightest. What about the rock? Okay, let's just pick so we're gonna make a cardboard car.
All right. So I am going to take 2 answers on things that they would use. Can I get some hands? Let me see. All right. Cardboard? Cardboard. What else? You gotta tell me everything you would use in the car. Cardboard. What else? We're supposed to be listening to our friend speak. Cardboard, straws, wheels. Okay, so cardboard and straws. Back there. Tell me what you guys would use.
Cardboard.
Cardboard. What else?
Straws.
Straws. So what, is it cardboard for the body?
For both.
For body and wheels, and straws for the axle and tape? Okay.
Because it's a lot.
Alright. So now, this will be the calculation you guys will do to get the average speed that your car goes. We won't be doing it today because we're not building the cars today. But to calculate the speed of the car, we will be calculating the total distance and total time. Okay? I shouldn't be hearing voices right now. Why do I hear voices? So, how might we use the materials to meet the criteria? How? You guys told me before, what will we do? Do you guys know what criteria is?
Yeah.
Oh, no? Who said no? Okay, can someone tell her what criteria is? Does anyone know what criteria is? Kiana? Okay, materials is part of the criteria, but criteria, girls in the back, stop talking please, because I'm gonna make you come back up here. Criteria is all the things that the car needs to meet. So for example, one of the criteria is that the car must travel 5 feet. Another criteria is the car must travel in a straight line. All right? So how will we minimize friction? Does anyone know what friction is? Yes, what is friction? Yes, when it rubs together. So how will we minimize friction? What are some things we can do to minimize friction? Well, not heat. How can we minimize things rubbing together? Meaning, how can we minimize, okay, how can we minimize the wheels from rubbing against the body of the car?
Watch this.
Space them out, what? Yes, we can space things out evenly. We can make sure the weight is properly distributed and everything is even, so there is less friction. How might you design your car to travel in a straight line? Where are my hands? Because I keep seeing the same ones. Back there, you. How can we make the car travel in a straight line? We spoke about it before. I said it not too long ago. Would you like some popcorn? What did you say? Yes, with the balloon, the air will help it go in the straight line. But in order for something to be straight, it has to be one thing. What is it? All right.